The differential forms of the fundamental laws. Tutorial number 5. A compressible flow occurs such that U equal 200xy, V equal 200x squared plus y squared, and W is equal to 0. So this is actually the velocity equation to describe the velocity profile that occurred by this flow. Find the rate at which the density is changing at the point 2 meter and 1 meter, where the density is 2.3 kilogram per meter cube. So this is the continuity equation that we learned previously. It can be simplified as del dp over dt plus rho del u over del x plus dv over del y plus del w over del z is equal to 0. And we know that the value of w is equal to 0, so we could substitute in this term and it will become 0. We could simplify this one. So and then we bring the value, the terms of rho del u del x plus del v del y to the right side. So we have dp over dt del rho, d rho over del t equal to negative rho del u over del x plus del v over del y. And then to substitute the value in this equation, we need to use the equation that given in the question previously to fulfill the value of du dx and dv dy. We know that u is equal to 200xy, so we have du dx is equal to 200y. And v is equal to 200x squared plus y squared, so we have dv dy is equal to 400 and y. And the coordinate is 2 meter and 1 meter, so we assume it is the coordinate of x and y, so we could write as 2 and 1 like this. So this is the equation to describe the changes of density here. So we substitute the value that we have. We have the density is 2.3, and then we have 200 according to this calculation. We substitute the value of y here, and we have 400 for dv dy. We substitute the value of y as 1 here, so we get the changes of density to the time is minus 1380 kilogram per meter cube second.